This is section 7.2 for my stats class, applications of the normal distribution. If you want to standardize a normal random variable, okay? Suppose the random variable x is normally distributed. It has a mean of mu, a standard deviation of sigma. Then the z-score, the standard score, okay, z is equal to x minus mu over sigma. So we have z is going to equal x minus mu over sigma. So it's whatever you're trying to normalize, the x value, minus the mean over the standard deviation. And that's going to give you how many standard deviations away from the mean you are. So it standardizes things like, for example, if you took the ACT and the SAT, both college prep tests, and supposed to tell you how well you're going to do in college and that kind of stuff, and you may get a scholarship based on one of the scores or both of the scores or something. And it's kind of funny, those things, like I live in currently a state that's considered an ACT state. Everybody takes the ACT in high school. Whereas a buddy of mine lives in a state, and in his state, everybody takes the SAT. I personally took both coming out of high school a long time ago. And and did much better on the SAT because half of it is math. And when I took it was half math and half verbal, and the half verbal part killed me. On the half math, I did fine. Whereas the ACT, only 1/4 of it is math, so therefore you go figure, right? Half of it being math helps me more than 1/4 of it being math because I can't read or write. All right, so figure 11 is here, and why do we look at figure 11? Because figure 11 shows the area to the what of the z-score, to the left. And it says of the z-score 1.33. So how on earth do I find that z-score? What we're doing, we're finding 120, okay? So our x is 120. Our mu in this case, that looks like a W. Our mu is 100, and our sigma, how far apart are these right here? 15. So our sigma is 15 here. So if I look at this, if I plug this in, I get z equals 120. That's not 120. Minus 100 over 15. So 120 minus 100 is 20 over 15. And that's going to be 4 over 3, which is 1.33. And we always stop z-scores at 2 decimal places. If it finishes like 1.325, then you could leave it a third decimal place. Sometimes that's accepted, especially like when it's 1.645, I believe is one of them. 1.645 is one of the ones that goes 3 decimal places, and people leave it all the time because of how it falls on the table. But 1.333333, we just stop at 2 decimal places because our table has 2 decimal places. Now this figure 11 is kind of zoomed in on something else. So what I want to do is actually go over to that file. I have it open here somewhere. All right. And let's look at, well, if I can make this work, let's look at this here. Okay. So 1.33. So the way that this thing works is we need to find the 1.3 row, okay? And then that's where that is, 1.3. And we don't know it because we can't see the top, so I'm going to have to go to the top. But there's the row we're looking for. So I'm going to scroll up to the top. And if you'll notice, the first column is 0.00. So like this right here is negative 3.30. You tack this number on the end of that. So here, this one right here is negative 3.31 for the z-score, okay? Would be 0.0005, all right? So that's how that works. So the way it works, if we don't see this top up here, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, and it ends with 9, okay? So let's go look back here at 1.3, all right? So here again is my 1.3. So this is 1.30, 1.31, 1.32, and here's 1.33. So the z-score, if z is 1.33, then that proportion is 0.9082. All right? 0.9082 is that proportion. And that is what falls to the left of that z-score. And that's what this was saying over here. So let's go back to note here, to our thing here. So to the left, okay, of the z-score. So this, see how this is darker from here back this way? This gray is darker than this gray? We shaded it, okay? We shaded it back to the left from there, okay? So it's less than that number. If we want the area to the right of a z-score, then we use the complement rule, 1 minus. That's all these two things right here say. If we want the left, we just look up the proportion on the table. If we want the right, we have to do 1 minus the area, okay? We have to do 1 minus the area if we want to go to the right, okay? That's all that's saying there. So let's look at this next page here. If we want to go between two z-scores, then we find this proportion for the bigger one and this one for the smaller one. And guess what? We do the bigger one minus the smaller one. It's that simple. Okay? And a lot of times I'll draw arrows over it like this. And I'll say, 0.9132 and then 0.0228. And then we subtract the 2 and get this area in here. Okay? That's how that works. So it's kind of like if we said, how far is it from Batesville to Senatobia? And we say, well, from Oxford to Batesville is 26 miles, and from Oxford to Senatobia is 56 miles. So how far is it from Batesville to Senatobia? 30 miles, or whatever it happens to be. It's not that far, but whatever it happens to be, okay? So if you wanted to find outside, like here, you wanted to find this little piece out here and this little piece out here, you find, 1 minus over here, and you find this one over here, and then you add them together because it's 2 separate pieces, okay? And they're not related, so you add them together. And then we have this little z alpha, z sub alpha, like the Greek letter lowercase alpha, pronounced z sub alpha. See, it says it right here. Z sub alpha is the z-score such that the area under the curve to the right is equal to that. So if I said the z-score sub 95, all right, the z-score sub, let's see, is that what I want to say is 95 or 0.95? Let me look and see what I want to say. I don't know. We'll see it later. So 95%, if I want to do 0.95, then that's going to be whatever z-score says, hey, everything to the right of that is that number. So maybe it's 2.26 or something, whatever. I don't know what it is. All right, I have to look it up. But we could look it up if I want to know what 95%. So look, inside here, these numbers are my percentages. That's 89.25%, 1.20123. That's 1.24, okay? So 89.25% or less than 1.24 standard deviations above the mean, okay? And that makes sense. If you're less than something above the mean, 50% is less than half of it. So it's got to be bigger than that if it's on the right side of the mean if you're talking about less. Okay, but if we're talking about right side greater than z.95 to the right is 95%, we need to look for 0.05 up in here, okay? So because 100 minus 95 is 5%, right? So we look for that 0.05, and if we go look for that, 0.05 is where? Well, in between these two, okay? Negative 2.5 and then between 7 and 8. So something like negative 2.575 would be z of the 0.95, where 0.95 is to the right, but I did the wrong one. I didn't think that looked right. I did 995, not 95, okay? So 0.05 is going to be a little further down. I did 2 zeros in front of it, which was what made it wrong. It's right here. It's these two. That's where that 1.645 I said earlier, okay? So negative 1.645 would be the z 0.95, where you have 95, the proportion 95 is to the right of that number. 0.05 is to the left of that number, okay? So that's where that z alpha comes into play there. So let's look at this homework in 7.2 because that's going to help drive some of this home and hopefully make a little bit more sense to see it worked out as opposed to just, here it is in theory. Let's just talk about it. All right, so here the notation z alpha is the z-score that is to the right of z alpha is what? Well, the proportion to the right of z alpha is alpha, all right? Fantastic, okay? And there's the pictorial representation of it, okay? We could pop it out and make it look bigger there, and you see it. It's to the right. This is the area to the right of z alpha, all right, is alpha. Determine the area under the curve, the standard normal curve that lies to the left of negative 1.71, 1.73, negative. So that's literally looking up these z-scores. Look up this z-score and then fill in the proportion right here. That's all that means. So I gave you the table. We can go look at it. But also if you click here, if you click right here, this opens up and gives us the table. Okay? So we have the table. Let me move this up here. And then we can scroll up and down. And we're looking for what? We're looking for negative 1.71. So here's negative 1.7, right? Here's 0 and here's 1. So it's not this one, it's this one. So it's 0.0436. And since it's to the left, we don't have to worry about 1 minus or anything else. We literally just read it off the table. So if we're looking for z is negative 1.71, this was 1.70, this is 1.72, this is 1.71, and it's negative. So then this number here goes in this box, 0.0436. So close this out, click in here, and 0.0436, I believe we said. Check the answer. Good job. All right. So then the area to the left of 1.73, again, click the table, find 1.73, keep going down, keep going down. Aha, there it is in blue right there, right? 1.7, this is 0, 1, 2, 3. So this number here goes in right here. It's less than 1.73. That's the proportion. 95.82% or 0.9582 is the area under the curve to the left of z equals 1.73. Right? So probably I should draw that picture. So if I have my normal curve here, doesn't need to really go back up there. Here's 1.73, and then everything under here is 0.9. I don't even remember the number now. 1.73, 9582. 9582. So let's do that. 0.9582. .9582. The area under the curve to the left of this. So we're going to have the curve again. This is this mu right here, right? And z is negative 1.21. That's over here, and the left of it is over here. So is that going to be greater than 0.5 or less than 0.5, right? Everything over here is 0.5, so it's less than that. So we need to look it up on the table. Look it up on the table. So let's open the table up. Negative 1.21. All right, there's negative 1.2. Here's negative 1.2. And then this is 0 and negative 1.21, which is 0.1. And that 0.1131 goes right here. All right? 0.1131 goes right there. And if you want to put 0.1131, you can. Then we hit check the answer. All right. And then finally here, this last one, negative 0.47. So again, we want to have the normal curve here. Mu's in the middle, right? Zero's in the middle, mu. And then negative 0.47 is somewhere here, right about here, right? And it's everything to the left of it. So I don't have to draw that. I just need to know it's to the left. So I look this up on my table, negative 0.47. All right, negative 0.4 is the top of that yellow one down there, right? So it's right here. And so this is 0, 1, 2, 3, 4, 5, 6, 7. Right? This one's 8 and 9. So that number there goes in this box here for negative 0.47. So 0.3192. 0.3192. 0.3192. And there we go. We got it right. Next question. Determine the area under the curve that lies to the right. So this time, what my picture looks like. So I have my normal curve here, right? Got my mu in the middle, and 1.58's out here. And this time, it's this little area over here. So when I look it up on the table, I'm going to find this piece over here. So I'm going to see if I can do this without erasing this. It may have gone away. All right. So over here, where's my? Oh, it did go away because I'm not in inside there. Okay. Well, it's to the right. So then if I pull this up here, let's see, I can open this up for the distribution table, and it's going to have negatives on this side. So when it has the 2 pages, this is the negative side. Well, I don't want the negative side. I have a positive. So page 2 is positive in this one. I don't know why they broke it up on this one and not on the last one, but they did. So 1.58. Here's 1.5. 0, 1, 2, 3, 4, 5, 6, 7, 8. That number does not go in here, okay? That's to the left. You have to do 1 minus that number, remember? Okay, so 0.9429. 0.9429. So remember that. All right, so 0.9429. So if we draw my curve here, 1.58's over here, right? Then everything from here over is 0.9429, but I want this piece over here. So this is 1 minus that number. So 1 minus 0.9429 is 0.0571, I believe. 0.0571. So let's try this number, 1 minus when it's to the right is what goes in here. Okay? So 0.0571. 0.0571. Fantastic. All right? Fantastic. To the right of negative 0.04. So again, look, we're going to have our curve here, right? And negative 0.04 is right here. I mean, just barely. And it's to the right of it. So it's just going to be a little bit bigger than a half, right? 0.5 is going to be a little bit bigger than that. So we're going to find this value from the table to be whatever, and then we're going to do 1 minus whatever we got right here, right? We're going to do 1 minus whatever we got right there. So it's a negative value. Pick this one. Go down here to negative 0.04, negative 0.0, and we got 0, 1, 2, 3, and 4. Okay? You can even see it here. Negative 0.04. So 4840, okay? 4840. So this is 0.04 for the Z is 4840 is what it is. So then again, we do this. We have our Z score right here. This piece over here is, so this is 1 minus 0.4840, right? To the left is 4840. I marked through it. To the left is 4840, 0.4840, and then to the right is 1 minus that. So that should be 0.5160 when you subtract, and that is what goes in the box right there, okay? 0.5160. And then to the right of 1.61, so I'm not going to draw it for you first here. We're just going to go straight to the table and look at it. That's the negatives. Never mind. Hang on. Let's go to the positives. 1.61. Well, let it open. 1.61. 1.6. This is 0, and this is 1. 0.9463. 9463. 0.9463. So if we draw our normal curve here, and we talk about 1.61, then everything to the right is 0.9463. So if we want the left. If we want the right, we do 1 minus 0.9463. 0.0537, I suppose. So 0.0537, if we subtract that, 0.0537, unless I've subtracted incorrectly. All right. And then to the right of 1.85, again, we need the positives, 1.85. We need to find that. And then we're going to have to do the complement rule, 1.80, 1, 2, 3, 4, 5. So 9678. All right. So 0.9678. So if we have our normal curve right here at 1.85, everything over here is that. So it's going to be 1 minus 0.9678 for the right side over here. And that's going to be 0.0322, I think. That number is what goes in right here. All right, 0.0322. So let's try that out. 0.0322. And fantastic. Next question. All right. So now we are going to go the area that lies between Z equals negative 1.19 and positive 1.19. So got my normal curve here. There's my mu. I got 1.19 here. And I got negative 1.19 here. So what I do is I find the area to the left of this one and the area to the left of this one. Okay. Once I find those two areas, I take this number and I subtract this number, right? Because I have all of it minus this little piece gives us everything in the middle here. I'm looking for this just in the middle. And I do that by subtracting the bigger one minus the smaller one. So we need to look up our values for 1.19 and negative 1.19. All right. So here, look at my curve here. 1.19. Let's find it first. All right. 1.10, 1, 2, 3, 4, 5, 6, 7, 8, the last one, right? 0.8830. 0.8830. So 0.8, you got to file that away. I'm not going to be able to write it down and leave it up here. So I'll write it down, but 0.8830, it's going to go away as soon as I go look for this. 0.8830, and then negative 1.19. Negative 1. I'm sorry, yeah, 1.19 is going to be here. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9, right? So 1130, 1170, right? So 8830 and 1170. So, oops. All right. So it was 0.8830 and 0.1170. So then I do the larger minus the smaller, 0.8830 minus 0.1170. 0, that's going to borrow 1 from here. It's going to be 6 and 6 and 7. So 0.7660 is the difference. That's what goes in there. 7660. So 0.7660. There it is. All right, so between the two, you subtract. The area that lies between z equals negative 2.61 and z equals 0. So here we have this curve. Z equals 0. Look, everything to the left is 0. That's 0.5. I know that already. That's 0.50005, whatever, 0.5. Half of it is 0.5. Negative 2.61. I'm going to find this little bit of area right here from my table, okay? And if you want to, when we look at this, like when we pull the table up, you can look up 0 if you want to. But look, 0, whether it's got a negative in front or a positive, because 0 is not negative or positive. It's because you go negative 0.01, negative 0.02, or 0.01, 0.02. That's why it's there. But either side of 0 is 0.5, okay? And the other one is negative 2.61. So negative, let's see, negative 2.601 right there, 0.0045, okay? 0.00. So this one is 0.0045, and this one is 0.5. So we do 0.5 minus 0.0045, punch that in your calculator, and you get 0.4955, I believe. All right, and that's what goes right here. Okay, 0.4955. Let's try that. 0.4955. And we got it. And then the area between negative 0.24 and 1.02. You still add them together. Still subtract the larger minus the smaller. I'm sorry. And by the way, let me say that while I said that because I'm remembering a book from previously. Your book does it this way. Some books do it differently, so you may see this different. If you take another stats class like business stats, or if you take another stats class at Ole Miss or somewhere else, the book may reference everything back to the center, and then it becomes a little different. But it's still drawing the picture and figuring out what's going on. For our book, we get all the proportions to the left, so we do bigger minus smaller on the proportions to get in between. So here we got this thing going on here. We got the curve, normal curve, negative 0.24, and over here 1.02. So we're doing in between. So we're going to find this minus this little piece here. Okay, so the 1.02, right, minus the 0.24. So let's come over here and find 1.24. Let's see. Oops, let's see, I'm going to try to keep them on the same screen. Negative 0.2 and 1.02. Oh, yeah, we can get that on the same one. Negative 0.24, negative 0.2, 0, 1, 2, 3, 4, right? And then 1.02, 1.0012, okay? So 0.8461 and 0.4052. So 8461, I may have said that wrong, 8461 and 4052. 8461 and 4052, right? 8460, what? 8461 and 4052. All right. 8461 and 4052. All right, I believe that's what they were. Okay, so this one is 8461, I hope. And this one was 4050. If it's not, it's just because I can't remember it. It's not because we're not doing the right thing. Okay, so this is going to be borrowed here 5. That's going to be borrowed down to 11. It's going to be 9044. So 0.4409 goes in right there. All right, so 0.4409. All right, fantastic. Good. Determine the total area under the curve between to the left of -2 and to the right of 2. Draw the curve and shade the area. So let's do this. Let's just look at them. D. Click here to view this graph. All right, so here's the graph. left of negative 2 is this way. Left of negative 2 is this way, and right of 2 is this way. We're in between the two, so that's no good. That graph's no good. Okay, so we can go ahead and get rid of this first one. Okay, so now let's try this graph right here. Again, nope, we don't want anything in here. We don't want anything between these two things here. We've already said it's outside, left and right of those two. So that one is garbage. All right, so that graph no good. Let's look at the next graph. Look at that. Here's negative 2 to the left, 2 to the right. That looks really good. So let's just look at the other graph to make sure. Oh, again, that's garbage. All right, we got stuff in here, garbage. So it's this one. It was graph C. Okay, well, if I can get this to work. It was graph C right there. Okay, so let's check it and see. And there it is, right? Left of negative 2, right of 2. The total area under the curve is, well, look at negative 2. Negative 2 is right here, and that's 0. Negative 2 is 0.0228. And I'm just going to tell you this. If you look up the other one, let's see, hang on. Let me close this out. So this is going to be 0.228 is left of it. That's okay. So we have this going on here, right? This is 0.0228. And if you're over here at 2, and this is negative 2, if you're over here at 2 on this side, these two things are the same size. You can actually just double it when it's the same thing. However, let's look it up and see, all right? So and that's actually the decimal. I got a 0 in there, 0.0228. Okay, I have it right here, but I didn't have it right over there. So let's look up on the positive side at 2. Wait a minute, that doesn't look like 0.0228, but that's 0.9772. So what's going on with this? What's going on with this? Well, remember, that's to the left. So when we come over here and we talk about 2, this is 0.9772. Well, over here it's 1 minus 0.9772, which is 0.0228. So then we got 0.0228 on that side, 0.0228 on that side, and so we just add those two together. Or you could multiply it by 2 since it's the same thing. But that's 444.56 with a 0 and a decimal. So 0.0456 is what should go right here, right? 0.0456. You have to add those two together, the 0.0228 on one side and the 0.0228 on the other side, all right? So now determine the area under the normal curve to the left of negative 2.48, I'm sorry, and to the right of 1.48. So what does it look like on a graph? Let's just look, to kind of draw it out first before we do this. So we got the normal curve here, right? And it really kind of tails off a little more on both sides. And we have negative 2.48 to the left, and then over here 1.48 to the right. Now these are not the same size now. This and this are no longer equal, right? We need to go figure out what those two things are. Over here we got to do 1 minus the proportion, and over here we just do the proportion on this side, just whatever it happens to be. Okay, so let's pick out what the graph looks like. So let's look at this one. Negative 2.48, 1.4. This actually looks really good. Okay, right? This could be around 2.48 and 1.48. We're outside of them. That one looks really good. Let's look at the rest of them to see. That one's garbage. Okay, this one is also garbage. And then what about this last one here? This one is also garbage. It's not outside those things. So it is most definitely A there. So we're going to pick A and choose it. And then it wants us to find it, so we got to go look the numbers up again. So let's go up here. Negative 2.48. Negative 2.4, and then 0, 1, 2, 3, 4, 5, 6, 7, 8. So 0.0066. Hopefully that's not hard to remember. 0.0066, and then 1.48. If we go 1.4 is all the way across this one right here, and this is 9, this is 8. So 0066 and 0.9306. So here we have 0.0066 and 0.9306, wasn't it? Now I don't remember. Now I got to look back. 0.0066, I know that one. Let's look at the 1.48 again. 1.48. It's the second one out here. 9306. 9306. Okay. 9306, 9306. So this is 0.9306, and this is 0.0066. And remember, when I drew it, this one was 0.0066 to the left here, right? This one's over here. This one this way is 0.9306. But I want over here 1 minus 0.9306, which is 0.694, 0.0694. So I need to add this number to this number. So 0.0694 plus 0.0066. We get 0, we add 1, we get 16, we add 1, we get 7. So 0.0760. That number there goes in here, okay? Because I had to do, look, this number was to the left of this one. So I had to do 1 minus it to get this number. And then I had to take this area over here and add it to this little area over here. And that's what I did right here to get 0.0760. All right? So 0.0760. And we have another one of these. Okay, this is the never-ending homework. This is just question 4. And we've been doing this for like 3 hours and 48 minutes. Okay, so determine the total area under the standard curve to the left of that number, to the right of the other number. What does the picture look like? Nope, left and right is outside. If it's left of a smaller number and right of a bigger number, that's not that one. Nope, it's not that one. It's going to be outside some stuff. There it is. Okay, so it is the last one, D there, right? And then we have to go get the values, right? And we add them together because it's OR. So let's go get the values here. This one's negative, and it was negative 0.17. So here we have negative 0.1, and this is the next to bottom row, so it's 987, 4325. So 4325 for that one, 4325 for that one. Oops. 4325 for that one. I'm going to write it down so I'll try to remember 4325, okay? And then we need the other one positive, which was 1.21. 1.201, 8869, okay? 8869. 8869, 8869. So 8869 and 4325, right? But again, what we want here is, for this curve here, we have this one over here at negative 0.17. This is 0.4325. I want this area over here, but also over here I want 1.21, and I want the area to the right. This is the area that's 0.8869, right? So over here it's 1 minus 0.8869, which is 0.1031, okay? This is equal to that. So then I take this area and add it to this area. So 0.4325 plus 0.1031, and I get 6535. So 0.5356, and that goes in here. 0.5356. 0.5356, 0.5356, 0.5356. All right. Uh-oh. So I did something wrong. I added wrong, or I did something wrong. So let's go back and check my numbers, okay? Kind of glad I messed one up for you so you can see. All right, so let's go back and check it out. To the right of that number, to the left of the other number. So it was 0.43. Let's draw the picture again. So it was 0.4325 when we talk about my normal curve here. And I was at negative 0.17. This area here to the left was this. And then or 1.21, this area out here. All of this was 0.8869. All right, and maybe my numbers are wrong. Let's try it one more time. So this is 1 minus 0.8869. Some of y'all might have been screaming, aha, 0.1131. That's where I messed up, right? 0.1131. That's what it is, not 0.1031. So some of y'all were screaming at the computer. There I go for, right, I'm obviously not using a calculator, okay? Obviously not using a calculator. Maybe I should get one out, right? 4325, 0.1131. Is that right? It's going to be 6545. So 5456, that's what goes here. So I found a mistake. Hopefully that's right. 0.5456. And so all of you who are screaming at the computer, you're vindicated now, right? And laughing at me. Ha ha ha, Mr. Guest, you missed it. Okay. what is the z-score such that the area under the curve to the left is 0.52? So here we're going the opposite direction. We are actually going to expand this out to 0.5200, and we want to find, right? We want to find whatever z-score, so that's bigger than half. It's going to be somewhere in here where this area is 0.5200. We want to know what this number is. So we've got to go find this inside our table and then go read the z-score from it. Okay? So let's open the table up and let's find 0.5200. So let's see. We're looking here. And so I'm looking inside all these numbers up here. All right? So 0.5200 is really close to this one, right? It's 39 away from that. That's 5239. This is 5199. So this one is really close. So this is on the 0.0 row, and it's 0, 1, 2, 3, 4, and that's a 5. So this is 0.05, okay? 0.05 is that z-score. So that's what the answer is going to be here. We're going to say this is going to be 0.05. 0.05. Fantastic. We went backwards. We looked up 0.5200 in our table, then we found the z-score that matched. So approximate that corresponds to the right tail area. So to the right. So here, now we have the curve here, and we're talking about out here is 0.1500, right? Take this as 0.1500 point, not up there, point whatever, right? So then 0.1500, it's everything out here to the right, which means that everything over here is going to be what? 1 minus 0.15, which is 0.85, and then we add 2 zeros to look on our table. So we're trying to find the z-score that is 0.8500. That's to the left of this z-score, but to the right will be 0.15. So let's go look up 0.8500 or 8500 in our table. 0.8500, not really 0.8500, okay? 0.8500. Keep looking high. Here we're close. We're close. All right. 8500 is right here. This one, 8485, is 15 away, and this is 8 away if I talk about the last two digits. So this one is closer. So I'm going to say 1.0, 0, 1, 2, 3, 4. Okay. So it's 1.04 is what I'm going to say is the answer. All right. So 1.04. And sometimes I haven't figured out why they go one side or the other sometimes, but I try to go to the closer one and see, and it took it there. Okay, 1.04. Find the z-scores that separate the middle 83%. So what on earth, when we talk about middle 83%, again, pictures tell us all we need to know here, okay? So we got our normal curve here, and then we have some z-score on each side, and in the middle here is 83%. Okay, which all this stuff in the middle is 0.8300, which means that we have some stuff over here and some stuff over here. So all the stuff on the outside is 1 minus 0.83, which is 0.17. But guess what? If it's the middle 83%, then this side is going to equal this side. So that means half of this, 0.17 over 2, is over here, and the other half is over here. So what is 0.17 divided by 2? It's 0.085. So then we have 0.085 over here and 0.085 over here. Now we saw this a little earlier. What happens when you have them the same? Once I find this z-score and it's negative, I just change the sign of it to get this one. Because if it's to the right and versus to the left, you just change the sign of the z-score and it's going to work. Okay. So let's look up 0.0. So really this number here is 0.0850 on my table. So let's look that up on my table. 0.0850, not 0.0850. And it's going to be somewhere 85. All right, here they are right here, right? 838 and 853. This is only 3 away, so this is the one I want. I don't want this one. So this is negative 1.3, and this was 987. That is a 7 there, right? So negative 1.37, negative 1.37 is that one. So we come back over here and we say, okay, when I draw this thing again, when I draw this, okay, this is negative 1.37, and guess what? This is 1.37, okay? So then the z-scores are, use commas to separate. So we're going to say 1.37, that's not 7, comma, negative 1.37. Did I type that in right? Yes. Put a comma to separate them. It shouldn't matter which one you enter first, positive or negative. Okay. All right, z of 0.22. What does that mean? Well, let's look at the picture, okay? Z of 0.22. So we have our normal curve, right? And we have some z-score, and this area over here is 0.22, which means this area is 1 minus 0.22, which is 0.78, and we add 2 zeros to it. So this area here is 0.7800, all of this over here, and we want to know this z-score right here, okay? So we've got to look up 7800, 0.7800 in our table and read the z-score. We're going backwards again, okay? So from what we started out doing. So let's open our table up and look for 0.7800, 0.7800. See, 0.7800. Here we go. They're in between that, right? This is 7794. This one is 7823. This is 23 away, and this is 6 away. So I want this one, okay? I want that one right there. So 0.7, and this is going to be 987. So 0.77, 0.77 is my z-score. 0.77 is my z-score. So let's see if that's what it is here. 0.77. And by the way, just because this doubles up doesn't mean that it has to double up. That's just a coincidence here, okay, if this is correct. Well done. All right. So now that we got through all those problems that were A, B, C, D, A, B, C, D, A, B, C, D, then we're moving along just a little better. So this problem is actually the same thing we just did. If alpha is 0.157, so we have this over here is 0.157. So then this area over here is 1 minus 0.157. So that's 0.8430 because you go to 4 decimal places. So 0.8430. So we want to find the z-score that corresponds to that area under the curve, 8430. So let's go over here to this one. The reason I did the positives because they're going to be bigger than 0.5. 8430, 84, here it is. This one's closer than this one, right? 8438. So it's going to be 1.001. That's a 1. So it's going to be 1.01. That's what goes in right here. 1.01. All right? So let's close this out. 1.01. 1.01. All right. So now we're finally done with 10 of these 17 in the never-ending homework. Okay. We can just go ahead and call it the never-ending homework. All right. Because here we have, is this going to be more? Or is this going to be the same thing? It's maybe a multi-part question. Assume the variable is normally distributed, compute its probability, draw a normal curve, and shade it. Okay. So which of the following normal curves corresponds to P of X is greater than 40? Well, mu is 50. Standard deviation is 70. So 40 is less than 50. And we want to do what? This says greater than 40. That's to the right. So this is only from 40 to 50. This is left of 50. So it's neither one of those. This is to the right of 40. So it's this one right here, C. It's C. Okay. We drew the picture. It is C. Well, okay, there we go. So continue to see more. All right. Find the probability that X is greater than 40. Well, to do that, we need to standardize it. We need to find the standard score for 40. So remember, Z equals X minus mu over sigma. This is the meat of Chapter 7 right here. We've finally gotten to the point where this is it, and we did a lot of practice to get here. Okay? So Z equals, I'm looking for 40, and then minus my mean is 50 over my standard deviation of 7, so that's negative 10 over 7. So if I punch that into my calculator, all right, if I punch that into my calculator, I get something like 10 divided by 7, a negative 1.43. So negative 1.43 is my z-score. I've got to look that up on my table to get my proportion to find my 4 decimal places right here, okay? So I've got to look up negative 1.43. That doesn't go in my answer box. I've got to look it up. So let's find my table. Negative 1.43, negative 1.4, 0, 1, 2, 3 is 0.0764, and that's what goes in right here. 0.0764. 0.0764, all right? 0.0764. I don't think you have to hit it twice. I think it's just the way my board's doing. I did, I found less. What did I not do? I looked up on the table and forgot to do what? We're looking to the right. We're looking to the right. So I need to do what? 1 minus that, right? I need to do 1 minus that. So I need to do 1 minus 0.0764, which is 0.9236 maybe? 0.9236. So let's check that answer out, all right? 0.99236. Look, it even knew how I missed it. Look at that, right? Because I forgot to subtract it from 1. Okay? Here, P is between 35 and 63. The mu is still 50 and 7. So between the two is which one? The only one between two values is over here at C, right? So that's it. And then it wants us to calculate that. So we've got to now find z-scores. We've got to find a z-score for this one and a z-score for this one, although that's not where I'm looking. I'm looking at this one over here, right? So 35, the z-score is going to be 35 minus 50 over 7, which is negative 15 over 7, which is negative 2.14. Is that what that is? Let me get my calculator back out. All right, 15 divided by 7. 2.142, yeah, so 2.14. All right, and then 63, so Z is going to be 63 minus 50 over 7, so it's going to be 13 over 7, which is 1.86, I think. Let's see, 13 divided by 7, 1.857, which is 1.86. So that z-score is 1.86. So we need to find the area to the left of 1.86 and to the left of negative 2.14, and then subtract those two numbers. Wow. All right? So I've got to try to remember that. Okay? So Z 1.86, okay, and negative 2.14. Right? I'm going to start writing stuff on the board or something off to the side. I mean like the actual whiteboard in the room, so I can remember these things. So let's go over here and look at the table. I need to find, we said negative 2.14. So negative 2.101234, 0.0162, 0.0162. All right, 0.0162, and then I need to go find 1.86. Okay, 1.86. So here's 1.8. 0, 1, 2, 3, 4, 5, 6, right? And then 7, 8, 9. So it works out. So 9686, 0.9686, 0.9686, okay? 0.9686. So then let's come over here, and now I'm writing them down because I just can't remember all this. So we have from this point over is 0.9686, and from this point over is 0.0162. So to find the area between the two, we just say 9686 minus 162 in decimals there. Okay, 4259. That worked out nice. Didn't have to borrow anything. 9524, and that's the area between the two that goes in right here. Okay, 9524. So 0.9524, and I wrote an extra digit or typed an extra digit. 9524. Hope that's right. So I typed it wrong. Good deal. Next question. All right. This is the same thing. This is exactly the same thing I just did. So what I'm going to do is skip it. It's the same thing I just did. All right. This one, it's the same thing. It's the same exact thing. What's the next one? Let's look at what the next one is. Find the 80th percentile. Okay, percentile, you've heard this term before. This is something like, and if you need help on the other two, just go back and watch that one I just did. Literally, it's the same thing, just with different values in it. Okay, different values, and those two between are just the same thing, unless I looked at it wrong and it was outside. Let me go back and check just to make sure. Yeah, between. It's between. It's between. All right. Still between. Find the 80th percentile here. So what this means when you talk about percentile, like if you took the ACT and you know your English score was the 61st percentile, that means you scored better than 61% of the people in the nation that took the ACT the same time you did. The 61st percentile means you're at or above 61% of everybody that took it. So, you know, like the other place I've seen it a lot is with my children. I go to the doctor and they say, well, your son's in the 51st percentile of height. Well, that means he's exactly average at 50%, right? So, or my daughter, when she was in 3rd grade, she was like in the 78th percentile. Well, now she's normal. She's like in the 52nd percentile. She's not tall anymore. She was tall for a long time, and then now she's not anymore all of a sudden. Okay? So find the 80th percentile means I have my normal curve, and then I want to find some value such that everything underneath it is 0.80, which you make it out to 4 decimal places, 0.8000. I want to find that z-score. So literally I look at 0.8000 on my table and read the z-score, and that gives me the z-score, the 80th percentile, okay? The 80th percentile. So the z-score to 2 decimal places. So let's go look that up. Look at my table. Look at 0.8000 there. It's going to be on this page somewhere. And it is right in between these two. This is 5 away and this is 23 away. So I want this z-score right here. It's 0.801234. So 0.84. 0.84 is this one, right? So 0.84. So for the 80th percentile, you need your z-score to be 0.8, not 5. I think I hit it right, 0.84. All right, so then what did I do wrong? Obtain a normal value to the fact that x equals mu plus z sigma. Oh, I did the z-score. It doesn't want the z-score. It wants the actual x value. I'm sorry. I did the z-score, okay? So the z-score is 0.84. So then I should have done the whole z equals x minus mu over sigma. So now I know 0.84 equals x minus 50 over 7, right? So if I move the 7 over here, I multiply it. 7 times 0.84 equals x minus 50. And this is getting to the formula they showed us just then. I did the z-score, and I should have, it wanted the x value, all right? So 7 times 0.84, not 7.84, but 7 times that, plus 50 equals x, right? I'm going to add 50 to both sides. So 7 times 0.84, I want to get calculator out to do that. 7 times 0.84 plus 50 is 55.88. So the actual score is 55.8, or the value there's 55.88. That's what that should have been, 55.88. All right, so let's see if this is correct now. All right, good deal, good deal. All right. Here, this is basically what we've done, just finding z-scores. So when we talk about between these two, you find the z-score for this, a z-score for this, you subtract the two. Fewer than 1,100, you do left of that. More than 1,225, you find a z-score and you do 1 minus. And then what is the percentile rank of a bag that contains 1,425 chips? You find the z-score for 1,425 and then work backwards like we did, okay? Or actually, no, on that one we don't work backwards. We actually find the z-score and we look up the percentage, and then 2 decimal places there probably is what they want that. All right? So those are things that we have done already. Let me look at the last question here and see what it is. Oops. I need to have on my mouse clicker to do that. All right? So the last one, mean, that's the mean, and it gives you the standard deviation. It says what proportion of hybrids gets over 61. Again, that's find a z-score and do 1 minus because it's over, it's greater, it's to the right. 51 miles per gallon or less, that's find the z-score for 51. And then less than is just read the table. Between 57 and 61, you find the 2 z-scores and you do the upper minus the lower. And then less than 46 miles per gallon, find the z-score and find the probability that it's less than that. It's literally the same thing that we've been doing on all of these. And this is already a super lengthy video. So try these out. Try to do these and work on them. And then if you run into major issues with some of the ones that I did choose to skip, again, they're like other ones, but I know that it'd be so much better if you were in the room with me and we could talk this out and work some of these together in the room. But we can't do that right now. It's just the hand we were dealt. So hang in there, do your best, don't drop. You can wait till the very end to decide if you want to drop. So let everything sort itself out, and let's just see where we are. Just take the next test, take the test after that, and let's just see where we're at before you get to the final, okay? And even if we have to come in, and I hope we get to come in and take the final together. That would mean an end to most of this craziness, but who knows at this point? It looks like we may not get to do that, or we might. I don't know. Nobody said one way or the other here, but you just don't know. It's just crazy right now. All right.